SOHCAHTOA. Yeah, you know what it is. When I'm doing math, I do it big. Yeah, screaming that's nothing. When I'm doing math, that's stunting. When you see me in the class doing math, I'm using SOHCAHTOA.
SOHCAHTOA.
Put it down from the whiteboard to my notebook.
SOHCAHTOA.
Learn the trig ratios or you're gonna lose. Sine is opposite over hypotenuse. Why you look confused? Which one you gonna choose? Cosine's adjacent over hypotenuse. We're not done yet, don't get complacent. Tangent is opposite over adjacent. Yeah, you know what it is. When I'm doing math, I do it big. Yeah, screaming that's nothing. When I'm doing math, that's stunting. When you see me in the class doing math, I'm using SOHCAHTOA. I put it down from the whiteboard to my notebook. SOHCAHTOA. Yeah, I'm using SOHCAHTOA. Attacking these problems like Rocky Balboa. Geometry till I DIE. Shout out to my boy Pi in the 314. My boy E up in the 271. My boy Derivative. My boy Square Root. You know I got you, baby. Math World Records.
So hopefully that woke you up this morning, because today is Monday, April 20th. We are way more than halfway done with this month. So let's get started with today's lesson. Just to let you know that the Greeks invented trigonometry, and for this reason we use the Greek alphabet to name angles. So if you see these little weird shapes of letters, that's really the Greek alphabet. So alpha, beta, and theta usually, and we're going to be using theta a lot. So it's just a circle with the little line through like that, just in case you wonder what that is. It's just the Greek letter theta. So the three basic trig functions are the sine, which is opposite over hypotenuse, and that's where you get the SO from. And then so SOH. So cosine is the adjacent over hypotenuse, so then that's where you get the ka. So ka. And then tangent is the opposite over adjacent, so you get the TOA. So TOA, TOA. And then that's where you get SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. And there are many other little songs that you can find on YouTube that will help you remind you of the three basic functions. And then, of course, because these are fractions, you have the reciprocals. So the reciprocals for these trig functions are cosecant, secant, and cotangent. So remember that for math, we always have abbreviations. This is the sine. This is the cosine. This is the tangent. So I better not hear you guys say sin, because the sin is, that's a religion thing, that's not math. And then this is the cosecant, which is the hypotenuse over opposite. It's just the reciprocal of those two. And then this is the secant, which is the reciprocal of the cosine, which is hypotenuse over adjacent. You're just switching these. And then the cotangent. So I better not hear you guys say cot or the sec. Okay, so now we're going to use these over here, those trig ratios, to do this. Now, it is key. It is fundamental that you guys label the triangle first. Label the triangle. Labeling the triangle is key. So we want to find the tangent and the sine and the cosine of angle A. So we are focusing on this angle. So then we're gonna, well, this is the hypotenuse. This side way over here, that side is the opposite because it's way on the other side of angle A. And this is right next to it, so that means adjacent. So now that I have labeled a triangle, I can find these. So remember that the tangent is the opposite over adjacent. So the opposite over adjacent will be 8 over 15. And then the sine is the opposite over hypotenuse. So opposite over hypotenuse is going to be 8 over 17. And these are fractions, so it's okay if you use a slash like that or go like that. And then the cosine is the adjacent over hypotenuse. So that would be 15 over 17. Okay, so let's move on to the next example. The next example, you just have letters, you don't have numbers. So what is the most important thing for you to do? Labeling the triangle. And we want to find the cosine of x, tangent of x, and sine of x. So we're focusing on this angle right there. So that means that this is the opposite, because it's way on the other side. This is the hypotenuse, and this is the adjacent side. So then for the cosine is the adjacent over hypotenuse. So adjacent is D over the hypotenuse is E. The tangent of x is opposite over adjacent. So opposite is F and adjacent is D. So this one's going to be F over D. And then the sine is the opposite over hypotenuse. So this is going to be F over E. See, you don't need numbers. You can figure it out as well. Okay, let's move on to the next example. It says, find the sine of theta, where theta is the angle shown. So here's the angle theta. And remember that labeling is key. If you label your triangle, then you should be okay. So then if you're focusing on this angle, then this is your adjacent. This is way opposite over here, so that's your opposite. And then this is your hypotenuse. But notice we want the sine, and the sine is the opposite over hypotenuse. And we don't know what the hypotenuse then is. So then we have to use the Pythagorean theorem. So what we're going to do is we're going to do 8 squared plus 15 squared is equal to c squared. So this is 64 plus 225 equals c squared. If you add those two, that's going to be 289 is equal to c squared. Take the square root now. So c is 17. So the hypotenuse over here is going to come back to be 17. Now we can find the sine. The sine is the opposite, which is 15, over the hypotenuse is 17. And so we're going to do one more over here. So what is key? You have to label the triangle. That is key. And we want to find the secant, the cosine, and cotangent of angle theta. Here's angle theta. We're not going to use any decimals, so that means everything has to be kept as a whole or whatever. Like if you have a radical, you have to keep it as a radical. So we know the hypotenuse, and we know the opposite, but we don't know what the adjacent side is. So to figure out the adjacent side, we have to use the Pythagorean theorem. We have to use the Pythagorean theorem. So we're going to do that. And once you do that, let me use some more white paper here. We're going to get, so we're using the Pythagorean theorem. Sorry. Oops. We're going to put a squared, so that'll be your 8 plus 8 squared is equal to 11 squared. So that's going to be a squared plus 64 is equal to 121. Subtract the 64. So then that's going to be a squared is equal to 57. Take the square root, but we don't want decimals, so we're just going to keep it as the square root of 57. So over here, we're going to go back to our triangle, and we're going to put that square root of 57. Okay, and so now we're able to answer these questions right here. So the secant, remember the secant is the reciprocal of the cosine. So it's the hypotenuse over the adjacent. So hypotenuse is 11 over the adjacent square root of 57. So then that would be your answer. The cosine, that's the reciprocal of this, so that's the square root of 57 over 11, or you could just say adjacent over hypotenuse. The cotangent is the reciprocal of the tangent, but you know that it's the adjacent over hypotenuse. So the adjacent, not hypotenuse, opposite. So it's going to be the adjacent, square root of 57, over the opposite, which is 8. And this is how you do these problems. And now you have an assignment on Alex. You can click on the assignment link from Canvas Modules Today's Agenda, and it will take you directly to the assignment. Have a wonderful day.